Alright, so now that we have done the formulae of trigonometry, let's start with these questions, right? This is the first question. It says sine square 43 degree plus cos square 43 degree. For that, we need a formula that is sine square theta plus cos square theta is equal to 1, irrespective of the theta value. Look at this closely. This is sine square 43 degree, cos square 43 degree. The only condition is theta angle has to be the same. So this is equal to be 1. That's it. So nothing else had to be done in this question. Okay. So only this formula has to be memorized. So if you remember the square formula we have, in which we had done cos square theta plus sine square theta equal to 1. We also had done sec square theta minus tan square theta equal to 1. And we have also done cosec square theta minus cot square theta equal to 1. Okay. Now let's take up the next question. Here it says, which of the following pairs has the trigonometric ratio having same value? Right. So let's first give them some name. That is A, B, C, D. Alright. Now it says, which of the following has the same value? So this is a pure question based on the value. Let's say A. Sine 45 degree is equal to 1 by root 2. Tan 45 degree is equal to 1. Are they equal? No. They are not equal at all. Okay. Then B value. B has cos 30 degree. Now cos 30 degree, we have to remember these values, that is root 3 by 2. And tan 45 degree. Tan 45 degree is equal to 1. Again not equal. Let's say C. Sine 30 degree equal to 1 by 2. Cos 60 degree. Alright, that is also equal to 1 by 2. So this is the correct situation. So answer is C option. Alright. If you check the third one, last one also, tan 60 is root 3, sine 45 is 1 by root 2. So they are also not equal. So answer is C option. Okay. Now let's take up the next question. Now this question said, which of the following is not an identity? Now sine square A plus cos square A equal to 1. This is an identity. Sine A is equal to tan A into cos A. Let's check. We have tan A equal to sine A divided by cos A. So from here by cross multiplication, we can have sine A is equal to tan A into cos A. Let's check again. The second option is sine A equal to tan A into cos A. Right. So this is also correct. Now the third one, 1 plus cot square A equal to cosec square. Oh, this is a direct square formula. Right. So this also is correct. Now the last one, 1 minus sec square equal to tan square. Right. This is wrong because we have 1 plus tan square A equal to sec square A. This is the real formula. So from here 1 minus sec square A should have been equal to minus tan square A. Right. Here in the fourth option it says 1 minus sec square A is tan square A. Right. So this is wrong. This is not an identity. Not an identity. Right. So what is the question saying? Which of the following is not an identity? So the answer is D option. Right. Be careful. What is the question asking? Which of the following is not an identity? So the answer is D option. Alright. Now the next one. Now this question again is related to the range of trigonometric functions or trigonometric values. Which trigonometric function can be equal to or greater than 1 but not below it? So if you remember, I'll write it here. Sine and cos both belong to the set of values from minus 1 to 1 inclusive of both. They cannot be beyond. Right. So they have to be less than 1. Can't be greater than 1. So in this case, which trigonometric function can be equal to or greater than 1 but not below? Right. So sine is wrong, cos is wrong because they have to be below 1. Okay. Now if you remember tan values, tan and cot, both these values belong to they belong to the set from minus infinity to plus infinity. Oh, so that means my tan and cot values will be below 1 as well as above 1. So that also is wrong. So clearly secant is left. So that is the answer of the question. But let's check. What happens in sec and cosec? What you have to understand that sec and cosec are simply inverse of sine and cos. Right? Sec is 1 by cos and cosec is 1 by sine. Now we know that the sine and cos are between minus 1 and 1. So their inverse will definitely be more than 1 or below minus 1. Right? So greater than 1, it will only be sec and cosec. Alright, so they have, and in fact if you have done earlier, it is between minus infinity to minus 1, inclusive of minus 1, union 1 to infinity. Right? Here there is one clarification that is required. Which trigonometric function can be equal to or greater than 1? And we consider only for positive values. Alright, so just for positive values it has to be above 1. So in that case only secant or cosecant could have been the answer. Okay, now let's go to the next question. Now this question says simplify this expression. Alright, let's do the simple process. Let's take LCM of these two expressions. It will be 1 plus cos alpha into sin alpha, and in numerator it will be cross multiplication, so it will be sin alpha into sin alpha, that is sin square alpha, plus 1 plus cos alpha into 1 plus cos alpha will be 1 plus cos alpha whole square, right? So it will be equal to sin square alpha plus 1 plus cos square alpha. If you open it will be 1 plus cos square alpha plus 2 cos alpha. It is a simple application of a plus b whole square. Divide by 1 plus cos alpha into sin alpha. Now you see sin square alpha plus cos square alpha will be equal to 1, and there is already a 1. So it is 1 plus 1 plus 2 cos alpha divided by 1 plus cos alpha into sin alpha. So it is equal to 1 plus 1 is 2, 2 plus 2 cos alpha divided by 1 plus cos alpha into sin alpha. So in numerator if you take 2 common you will get 1 plus cos alpha, and in denominator we already have 1 plus cos alpha into sin alpha. So what will happen? 1 plus cos alpha will get cancelled, and the final answer will be 2 divided by sin alpha. Now it is sin alpha in denominator. If it goes in numerator it will become cosec alpha. So 2 cosec alpha is the final simplified form of this expression. So this expression is equal to 2 cosec alpha. Right? So this is the answer of this question. Now the next one. Now this question says sin alpha is equal to 5 by 13, right? And alpha is between 0 to pi by 2. Now this only means to say that all the values, all the trigonometric ratios are positive. Now we have to find cos alpha, tan alpha and cot alpha. There are two methods of doing this. One method is the triangle method. So let's simply draw a right angle triangle and assume one angle to be alpha. So if this is A, B, C, then sin alpha will be equal to, from this triangle, AB upon AC, opposite side upon hypotenuse. And the value of sin alpha is given in this case as 5 by 13. So very safely we can take AB equal to 5, AC equal to 13. And from there, AB equal to 5 and AC equal to 13. From there we can simply calculate the value of BC. Now for BC we have a square root of AC square minus AB square, that is 13 square minus 5 square. Or we can also use the Pythagorean triplet, because we know that 5 is to 12 is to 13 is one Pythagorean triplet. Here we already have 5 and 13, so the third side has to be 12. So whether you do it by calculation or if you memorize the ratio, in any case this has to be 12. So this side is 12. Now once you get all the three sides, you can easily calculate any trigonometric ratio. Say for example cos alpha. Cos alpha will be equal to, adjacent side upon hypotenuse. So adjacent side is 12, hypotenuse is 13, right? So if suppose we have to calculate tan alpha will be opposite side upon adjacent side. So it is 5 upon 12, right? Now, so we have already sin alpha, cos alpha and tan alpha. By inverting them, we can get cot alpha, sec alpha and cosec alpha. So cot alpha will be equal to 1 by tan alpha, that is invert of tan alpha, 12 by 5. Sec alpha will be equal to inverse of cos alpha, that is 13 by 12. And cosec alpha will be equal to inverse of sine, that is 13 by 5. Right? So this is one method of doing this question. Now the other method can be, let's look at this carefully. Method 2 can be taken as, we can take help of formulae. We have a formula sin square alpha plus cos square alpha equal to 1. And it is given that sin alpha is equal to 5 by 13. So put the value of sin alpha in this and calculate cos square alpha. So sin square alpha will become 5 by 13 whole square plus cos square alpha equal to 1. So from here we have cos square alpha equal to 5 by 13 square goes to the other side. So it is 1 minus 25 by 169. So if you simplify, in denominator 169, numerator 169 minus 25. So it is 144 by 169. So cos square alpha is equal to 144 by 169. So this gives us cos alpha is equal to, take the square root, 144 will give us 12 and 169 will give us 13. So now we have sin alpha as well as cos alpha. From there we can calculate tan alpha. Tan alpha will be equal to sin alpha divided by cos alpha. Now sin alpha is 5 by 13, right? Divide by cos alpha, that is 12 by 13. So 13 and 13 will get cancelled and we will have just 5 by 12, right? Similarly, if you invert all of them, you'll get sec, cot and cosec. So this is I think sec cot alpha will be simply inverse of tan alpha, that is 12 by 5, and so on. Okay, so there are two ways of doing such questions. Now let's take up the next one.